Assalamualaikum and good day. Topik kali ini adalah cost justifying ergonomic improvement. Saya Associate Prof. Dr. Ezrin Hani, your course coordinator. Okay, for this topic's lesson outcome, at the end of this topic, students should be able to first identify non-value added tasks and motion waste, and second, to calculate the productivity impact after ergonomic intervention program. The reason why we need to make an ergonomic improvement is some of that is because of the regulatory compliance, and we also need to from time to time health and safety performance. Nak kena improvekan performance, safety and health tu. So we need to conduct the ergonomic improvement and also production enhancement. So if we need to conduct the ergonomic improvement, we need to justify the cost. So di dalam kelas inilah kita akan tengok macam mana kita nak justify cost untuk some improvement that is to me is a very simple, murah. Kita belajar sama-sama. Ergonomic has many benefits. For example, by having ergonomic program in the workplace, it can help management to remove pain from workers. And also with the ergonomic program, it can provide comfort. So by having comfort at the workplace, we believe that the staff or the workers will have high satisfaction to the job. So by having those removing pain and also comfort in the workplace, it will decrease injury related costs, increase production performance, and it may lead to cost savings in other areas, including quality and delivery. Alright, some people think that you want ergonomic, you have to spend money, and it's costly, expensive. But the thing is that sometimes we don't have to spend any cents. What we can do is just to rearrange ataupun susun semula ruang kerja, workstation, make some improvement. And by research also shown that there is effective way to cost justify ergonomic improvement by productivity improvement. Dalam lecture kali ini kita akan lihat bagaimana dengan rearrangement ataupun susun semula workstation, you boleh justify ada perubahan atau penambahbaikan in terms of ergonomic, which is some of the improvement can prove save money. Productivity is measured at the workstation level, so it fits easily into typical cost justification processes. It's also simple to predict and quantify the productivity impact of ergonomic improvement. There are many methods that prove ergonomic can affect productivity. However, in this class, I will share about two methods. First is we try to increase the productivity by eliminating non-value added tasks, and the second one is by paying attention to reduce motion waste. So macam mana tu? That some of the activity that we need to perform di dalam tempat kerja kita, some of them is ada wujudnya unnecessary step yang mana kita akan assess atau evaluate adakah boleh kita remove non-value added task ni. Tak ada value, task tersebut tidak memberi apa-apa nilai tambah. Contoh nilai tambah untuk menjadikan produk yang dihasilkan bertambah baik atau mempercepatkan proses, atau sebenarnya task tersebut kalau tak buat pun tak apa. So bila mana task tersebut okey je kita tak buat because of dia tak ada value, so why not kita eliminate so that we pendekkan proses tersebut. Bila pendekkan proses tersebut, kita dapat jimat beberapa minit, mungkin saat, yang mana bila kita kumpul, dia boleh menjimatkan banyak masa. And the second is reduce motion waste. Motion meaning that kalau kita siapkan satu kerja ni, kadang-kadang kita tak sedar kita berjalan jauh because we want to reach something, some tools that is required to perform the job. Katalah motion tersebut kita dapat reduce, and kita dekatkan tool tersebut ke tempat kerja kita. So apa yang berlaku ialah kita dapat reduce motion waste. So bila mana kita dapat reduce motion waste, kita juga dapat menjimatkan masa dan seterusnya menguntungkan company, dan mungkin nanti kita boleh buktikan will increase productivity. Alright, this slide is showing the type of works in operation, which can be categorized into two: value added work and also non-value added work. So as I have explained in the previous slide, non-value added work is task and operation that a customer is not willing to pay for and not make the product more valuable to the customer. Meanwhile, for the value added tasks, the above one, tasks and operation that make the product more valuable to the customer. So aim kita nak eliminate the non-value added work. Step analysis, the step will help us to do what we want to do. First, to eliminate the non-value added task, and the second one is to remove the motion waste. And let's have a look into step analysis. The step analysis is developed by Human Tech in 2009. STEP is stand for Standard Time Efficiency Process. It's a tool for motion economy. So dalam kuliah ni ataupun lecture ni, saya akan ajar step by step lah bagaimana untuk conduct step sasul. Okay. In line with our objective, STEP is able to estimate the motion time savings from ergonomic improvement. So you need to perform ergonomic improvement, and mesti ada, bila sebut improvement, dia ada before and after. Alright, before improvement and after improvement. So you have to measure the improvement. Kalau macam yang first ni, untuk motion time saving, so kita kena measure the motion times that is saved by the proposed improvement. And the second one is to improve the improvement to reduce the reach or eliminate walking steps. So as I explained, if you can put the needed tools nearby, lebih dekat kepada you, you don't have to walk into the somewhere else to reach the tool. You letak dekat-dekat semua, so you can improve or eliminate the walking step. The walking step that is eliminated can be calculated, and kita akan nampak dengan buang steps yang walking step tersebut, kita dapat menjimatkan masa. Kalau bernasib baik, kita boleh improve the productivity. Alright, as you know, ergonomic assessment tool, it's designed to measure maybe a specific ergonomic risk factor, satu saja risk factor, ataupun combination of multiple risk factor, tapi tidak boleh kita katakan satu tool tu boleh measure semua. So nak kena faham di dalam ergonomic, itu kelemahannya lah, kelemahan yang mana kita difficult to combine all risk factors di dalam satu tool. Yang mana bila kita cuba combine, dia akan jadi satu tool yang sangat complicated, difficult to perform. Alright, so kalau dalam contoh, saya bagi contoh RULA, Rapid Upper Limb Assessment. Rapid Upper Limb Assessment adalah satu metod untuk membantu assessor ataupun ergonomics untuk measure penilaian posture pekerja yang melakukan aktiviti untuk bahagian anggota atas upper limb assessment. REBA, entire body assessment, so boleh menilai posture dan beberapa simple risk factors untuk keseluruhan badan. Tapi bila sebut kepada lifting load, kita akan kata, boleh ke RULA atau REBA buat? Definitely not. What we can go is, we will go to Nayos lifting equation. But need to remember, Nayos lifting equation is just for lifting and lowering, something like that. However, when you need to transfer goods, nak transfer barang tersebut, maksudnya mengangkat and berjalan untuk diletakkan ke satu lokasi. So, Nayos lifting equation mungkin tidak sesuai. So, begitulah untuk step ni. Nak kena ingat, step ni hanya boleh digunakan untuk reaching motion, walking motion, determining the relative effect of alternative improvement, and estimate time saving from job improvement. So, kalau yang lain-lain tu tak boleh nak measure lah. Kita tak measure posture menggunakan step. Kalau misalnya ada keperluan untuk measure posture and also motion movement or reaching and so on, so it is advised to have a combination of method yang sesuai supaya risk factors yang diukur lebih kurang ataupun estimation of the risk factors tu lebih tepat atau accurate. It is common sense, alright? Reaching to the farthest zone will take more time than reaching to the next closest zone. If you can see in the picture, tengok yang merah tu represent is labeled as A, B is labeled as yellow, C green, and D and E. E the kawasan yang paling jauh lah. So let's say you want to reach something at E, so dia jauh, dia need movement to reach up, compared to you put all in your wrist position, iaitu letakkan semua alatan yang kita nak gunakan di A. Jadi semua is tak perlu pun nak move, tak perlukan nak movekan tangan jauh. So with the idea of semakin jauh letak, semakin membuang masa. Macam itulah analoginya. Kita bukan nak menggalakkan supaya kita bekerja dengan statik. Ada situasi yang mana kita tak perlu nak letak jauh. However, it is important to ensure that we keep moving and active at the place. Okay, so the step zone dia kata apa? A is 0 to 15 cm. Okay, labelkan A sebagai jarak 0 hingga 15 cm. B pula 15 hingga 30 cm. C 30 hingga 45 cm. 45 hingga 60 cm. Dan seterusnya 60 hingga 75 cm. Kalau tengok dalam gambar tu macam dekat-dekat je kan, tapi sebenarnya jaraknya jauh. Dia is why dia akan consume certain amount of time. Yang mana bila you letakkan jauh, maybe you need to have a stool or ladder to pick the item at E, at E zone. Okay. So yang tadi tu A, B, C, D, E. Okay, ada zone A, zone B, zone C, zone D, C and D. Okay. So step method ni cakap apa? Kalau perlu, letaklah di kawasan paling 0 hingga 15, iaitu di kawasan A. Meaning that if you put the item or the tools that you need, you don't have to reach it. Tak perlu menjengkit contohnya. untuk mengambil alatan-alatan yang ada, okay, is the best. Letak paling dekat is the best. Jika letak jauh, dia akan ada penalti. Okay, tengok ni. Penalti yang pertama adalah di kawasan A. Kalau dia tak ada, kalau dia kosong neutral, terlampau dekat neutral lah, kosong lah. Tapi kalau dia ada letak je alatan atau something yang you need to reach at the area A, which is 0 to 15 cm, you kena set that is a penalty. You akan dapat penalty 0.2. Kalau you letak within the range of 15 to 30 cm, penalty dia 0.4. And then if you put the things ataupun alatan tersebut pada range of 30 to 45 cm, penalty dia 0.6 seconds, saat 45 hingga 60, 0.8 saat. 60 hingga 75, 1 saat. So bila kita letakkan saat dalam kita punya decision untuk meletakkan satu barang ni kita gunakan ketika kerja, kita mula berkira-kira ada penalti ni kalau letak jauh kan. Itu common sense lah. So letak dekat sikit lah, nanti penalti dia kurang sikit. Nanti saya akan tunjuk macam mana kita nak gunakan penalti ni dalam kita punya step analysis. So menarik menarik. Jadi tahu dah, makin jauh makin besar penalti, makin tak banyak keuntungan yang boleh dibuktikan. Okay. Alright, in the previous slide showing the penalty untuk reaching activity. So slide ni pula penalty untuk berjalan, untuk step. Okay, step analysis assign time saving for each step eliminated for walking task. You berjalan kan, you kena ambil barang contohnya, ataupun kena letak after you settle you punya task, you kena letak yang dah complete tu ke satu tempat. So memerlukan you berjalan. Okay, satu circle of workstation tu. Okay, so step kata kita letakkan penalti untuk langkah-langkah yang digunakan untuk menyelesaikan tugas. Jadi bila you letak penalti, again you can be more careful to set up the location yang nak letak barang tu. Semakin banyak step, semakin tinggi penalti. So let's have a look. Kata step analysis ni cakap apa? The first step, use to begin walking correspond to 0.8 seconds penalty. First tu 0.8 second penalty. And subsequent steps correspond to 0.5 second penalty. Just imagine kalau step tu banyak, kalau macam kita kan, biasanya ke mana-mana tak nak jalan, kadang-kadang menyinggah lagi, macam mana tu, menyinggah corner jumpa kawan sembang, banyaklah step dia. So based on this analogy, it make us careful to set up the workstation if we concern with the productivity. At the same time, we can reduce the movement so that the workers can concentrate to the job and complete the job early, and then we'll have more time to break, berehat, makan dan sebagainya. Estimating the economic improvement, benefits, cost recovery. So based on the ability to choose the best economic improvement for the available resources, we can use also the time saving from eliminating the value added tasks and reducing motion time. So these are the calculations. Tengok ni, productivity impact calculation. We can calculate the projected productivity impact by having total time saving. Okay, bahagi dengan total operation time darab 100. So kita dapat percentage of the impact yang kita buat improvement terhadap workstation. And we also have an option to calculate the conservative productivity impact. So meaning that we calculate the productivity impact. Let's say we katalah perubahan tu efficient sebanyak 65% sahaja daripada the total improvement yang kita buat. Sebab kita ingat setiap improvement tu, bila kita nak buat sesuatu improvement tu, it's not that kita ambil 100% ni efektif. So kita ada reserve lah sikit. Katalah dia efektif sebanyak 65%. Banyak challenge cabaran-cabaran yang ada tu kita ambil kira, and the effectiveness of the improvement only 65%. So kita boleh dapat juga conservative productive impact yang kita perolehi berdasarkan improvement yang dilakukan. Okay, now sampai masanya kita nak tengok macam mana sebenarnya nak buat step analysis ni. Okay, tugas ataupun task ini adalah untuk secure cartridge tray, untuk masukkan cartridge tray tu dalam printer lah. Okay, so sebelum kita boleh conduct the step analysis, kita kena listkan semua aktiviti yang dilakukan untuk pastikan the job atau task secure cartridge tray tu can be done. So katalah kita ergonomics, kita tak pernah pun menggunakan printer tersebut. So kita kena tanyalah orang yang biasa guna, orang yang biasa buat maintenance. So kita mesti dapatkan the whole process. Okay, so after we get all the whole process, di dalam contoh ini, you please give attention to the blue color, the left and blue color. So job improvement for reaching, nampak tak reaching? Bawah dia install tool balancer, move part tray to shelf. Job improvement walking, because dia memang perlukan walking untuk buat benda tu. Okay, so what they do ataupun dia propose apa sebelum ni kena jalan, dia kata cuba reconfigure workstation. Dia nak propose untuk reconfigure so that dia kan boleh reduce the walking distance. And job improvement, eliminate time, so dia integrate to process. Okay, so katalah you ada sebelum dan selepas proses. So apa yang you kena buat ialah, biasa kalau di dalam safety tak kira lah you conduct job hazard analysis, high right, termasuklah dengan ergonomic improvement, we need to have exercise, round table, it's not exercise, round table discussion. So kita discuss lah, cuba eliminate ni, boleh tak? Cuba kita combine, okay ke tidak? Okay. So as I did mention, kita kena consider sebelum dan selepas proses. Jadi let's have a look at the green color, current step zone, and di green color tu juga yang belah kanan dia tu proposed step zone. Kena consider kedua-dua sebelum dan selepas. Jadi for current step zone adalah sedia ada ni kan, sebelum kita nak buat improvement. Okay, sekarang maksudnya proses itulah proses sedia ada, current step zone. So we need to measure the reaching distance sebab kita nak set penalty. Okay, reaching from 15 to 30 cm. Okay, and then dalam current zone ni dia kata apa, from 15 to 30 cm, and dia kena reach to 45 to 60 cm. Okay, and for activity of install tool balancer, and the second activity, move part tray to shelf. Move part tray to shelf, reach from 0 to 15 cm, and need to reach from 45 to 60 cm. Baiklah, so itu yang current step zone. you kena ukur lah workstation tu berapa within berapa range distance dia nak untuk reach tersebut. You dah measure kesemuanya, kedua-dua aktiviti tu, and then you nak propose, you dekatkan you nak propose mungkin pemasangan tu dirapatkan lagi, and then bila you dah propose tu you jot down. Okay, sekarang ni memang kena reach. Kalau propose step zone memang reach, tak boleh nak ubah, memang 15 to 30 cm. And after that, walau bagaimanapun kita boleh dekatkan reach to 30 hingga 45 cm. Jadi dekat. Tadi kalau tengoknya sebelum ni reach to 45 to 60 cm. And untuk move part tray to shelf memang reach from 0 to 15 cm. Okay. Dan tak perlu nak reach kepada 45 to 60 cm. Reach tu tak perlu dah. So maksudnya dia reach from 0.15 to 0.15 cm as well untuk reach. Makanya ada berlaku perubahan yang mana reaching tu didekatkan. Dia dah eliminate non-value added task. Okay. Aktiviti untuk dilakukan, untuk siapkan satu aktiviti tersebut, install tool balancer, dia kena buat dua kali times per cycle. Satu cycle complete task tersebut 2 kali kena install tool balancer. Kena tulislah 2 kali. Meanwhile for move part tray to shelf, 1 kali cycle dia kena buat. So tulislah 1. And let's have a look at job improvement. Reconfigure workstation. Mula-mula dia kata current activity walking mesti akan ada first step ni sangat wajib kan, kena ada lah. So first step is 1, next step ada 8 step untuk ke tempat yang dia nak reaching dan sebagainya. Kan nak reaching tu ataupun aktiviti perjalanan yang dilakukan ketika menyiapkan task secure cartridge tray. And they propose with the dia mesti berkait dengan aktiviti yang atas tu. Dia dah dekatkan, so dia kuranglah jalan. Daripada 8 step jadi tinggal 3 step sahaja. Berapa kali dia jalan sepanjang tempoh tu? 1 kali. And then job improvement, eliminate the time. Kalau sebelum ni current task ada aktiviti yang dia berjalan tu, dia memakan masa 0.6 saat. Tapi apa yang dia buat bila mana dia dekatkan, dia eliminate kan, dia integrate to process. Apa yang dia propose tu, perjalanan tu dapat dulu guna 0.6 saat untuk 2 kerja sebab dia dah combine So dengan dia propose improvement tu, saat untuk proses yang lagi satu tu tinggal kosong. Macam tu. Jadi dia dah improve dia dah improve saat 0.6 saat, dia buang 0.6 saat tersebut lah. Okay, times per cycle untuk jika dia tidak integrate to process adalah dua cycle kerja yang diperlukan. Makanya bila mana dia dapat jimat 0.6 saat sebanyak 2 cycle, jadi kita boleh calculate lah penjimatan dia. Okey, itu cara kita nak isi table ni. And kemudian kita kena bagi value lah. Bagi value range from 15 to 30 cm. Okay, back to the install tool balancer for current step zone. 15 to 30 cm. 15 to 30 cm. Okay, berapa dia punya penalty? Kalau tengok kepada slide yang sebelum ni, adalah 0.4 second. Conteng lah nanti conteng. You guys have your own, nanti conteng 0.4 second. The reach to 45 to 60 cm, 0.8 second. Okay. And then tulis pula reach from 15 to cm, 0.2 second. Reach to 30 to 45 cm is 0.6 second. And then seterusnya isi. You letakkan nombor of penalties di dalam di dalam table ini. So, apabila you dapatkan nombor penalti dia semua, you nampak berapakah penjimatan, you tolakkanlah. Kalau range from, saya ambil contoh satu, install tool balancer, range from 15 to 30 cm, and tengok proposed step zone, range from 15 to 30 cm, dia sama value dia. Sama value dia iaitu 0.4. So, tak ada perubahan. Tapi, yang ada perubahan adalah 45 to 60 cm adalah 0.8 second penalty. Tapi dia dapat buat penjimatan 30 hingga 45 adalah 0.6. 0.8 tolak 0.6. So, dia dapat jimatkan 0.2 second. Okay, dapat penjimatan untuk install tool balancer sebanyak 0.2 second. So, 0.2 second ada 2 cycle, 0.2 second darab 2, dapatlah 0.4 second of time saving due to kita cut reaching activity, non-value added for reaching activity. Seterusnya, yang lain saya nak mohon untuk students for try it out. Okay, and then dapatlah 0.4 for the projected time, motion time saving, second per unit activity. And then if you still remember, macam mana dapat konservatif, kena darab 0.65, which is 65% of the projected time saving. Dan seterusnya, you akan dapat, let's have a look at the pink color, the left side. You akan dapat projected and conservative time, motion time saving for each activity. And then, you calculate lah total motion time saving for the projected and conservative. Untuk total, untuk total you akan dapat, okay, untuk projected dapat 4.7 second, and the conservative dapat 3.06 second. Panjang lebar kan? Cuba buat dulu, tak faham bertanya saya. Alright, in this slide also shows the same as previous, cuma kat sini nak tunjuk ni macam mana dia boleh dapat 0.26, 0.39. Kena darab dengan 0.65, iaitu 65% from the target, projected saving yang kita boleh obtain by propose the improvement. Nampak macam simple kan? Tapi ini adalah bila mana kita buat isi form tersebut, contohlah isi form the projected time saving, conservative time saving, what is that means? Kita kena faham juga. So what? Macam tu kan? So, lihat kepada jalan kerja ni current cycle time 15 second. Katalah satu cycle untuk menyiapkan sebelum kita improve the activity is 15 second per unit. Itu total. Okay? Pekerja ni memang itu kerja dia. Dia memang kerja install cartridge. So, dia kerja 7.5 hours. Dan kerja tersebut ada 2 shift. And dalam satu kilang tersebut ada 3 pekerjaan yang sama. Makanya, calculate total time saving per day. Bila kita tengok konteks yang lebih besar, iaitu syarikat yang menjalankan, yang bersetuju dengan improvement tersebut, berdasarkan kepada total motion time saving pada slide yang sebelum ini, kita project kita boleh dapat 4.7 of saving. 4.7 second per unit is saved. Satu current cycle time is 15 second per unit, meaning that in 1 minute 4 unit task can be completed kalau ikut yang lama. Okay, jadi kita kira slowly, kita kira. So time saving in 1 minute is 4.7 sebab berdasarkan 15 second per unit. 1 minit ada 60 saat. So kalau dia memang kerja dia nak buat tu 1 minit dia boleh dapat completekan 4 task. Okay, Sebab itu bila kita kira, okay, satu task kita jimat 4.7 second. Tapi 1 minit dia buat 4 task. So, total time saving in 1 minute sama dengan 4.7 darab dengan 4. Ke 1 minit dia akan jimat 18.8 saat. So, berapa penjimatan yang dilakukan kalau itu memang kerja dia? Selama 1 jam. 1128 seconds save. And satu hari berapa? 8460 darab 2 untuk 2 shift sahaja. Dapat penjimatan 16,920 second. Okey. Sekarang ni ada 2 shift dapat jimat. Tapi tengok balik. Satu hari dia ada 2 shift penjimatan 16,920 second. Tetapi dalam soalan ni macam soalan exam lah, dia ada tricky sikit. Kita dah seronok dah satu hari. Tapi lihat balik kepada ada 3 kerja yang sama macam dia ni. So katalah ada 3 kerja yang sama, kita nak tengok penjimatan kat 3 kerja yang sama macam kerja yang kita sedang buat analisa ni. Okey, yang tadi kita dapat kira satu hari untuk 2 shift, tapi ada tambahan 3 kerja yang sama. So ada 5 kerja yang 2 shift, and then ada 3 jobs alike. 3 jobs alike. So dalam satu hari ni 2 shift dah plus 3 jobs alike, bermaksud 16,920 ada darab dengan 3. Sebab 3 jobs alike yang sama juga dengan 2 shift. Macam tu lah. Okey, jadi dia ada penjimatan 50,760 seconds. Kira penjimatan dia berapa untuk 1 kilang? Penjimatannya adalah 846 minit projected time saving per day. Meanwhile, we kena consider lah ada challenge dan sebagainya. Mungkin boleh dapat penjimatan hanya 65%. So kalau 65% pun kita boleh dapat penjimatan conservative total time is 549.90%. Okay. Alright, baiklah. Tadi kita nampak penjimatan dari segi minit. Macam mana kita kira one by one. The total time saving, and then we consider all the tasks, the shift and the jobs alike. Kita dapat projected and conservative time saving per day. Okay, apa yang diberi dalam slide ini adalah per minutes. Okay, in minutes. So current cycle time 15 second per unit, working time 7.5. Mesti ada labor rate. Okay, labor rate katalah RM12 untuk 1 jam per hour. RM12 setiap sejam. So cuba kira berapakah projected money saving per day. Total time saving 866 minutes. So bermaksud 846 minit ni adalah 14.1 hours untuk the whole company dapat save. So katalah 1 jam dibayar adalah RM12. Makanya untuk 14.1 jam company dapat jimat 169.20 satu hari. Okay, and let's say we consider all the challenges and we take it only 65%, 0.65. So satu company tu dapat jimat 109.85 sehari, RM10 Malaysia. So untuk sehari, just imagine for sebulan or maybe setahun. So penjimatan macam tu lah yang kita nak buktikan. Dengan adanya work improvement, seronoklah kita nak present kepada top management. Okay, this is the things kan yang kita nak buat, yang kita boleh provide improvement, and this is the cost benefit analysis. Seronok bos tengok, mesti dia approve kita punya proposal. Now we calculate the productivity impact based on the following projected and conservative total time saving per day. So Total operation time per day 7.5 of the working time to complete one task. Darab 60 darab 2 shift and 3 jobs alike, so ada 2,700 minutes untuk total operation time per day. So productivity impact calculation, macam ni lah darabnya, nampak lah berapa kita save, and then bahagi dengan total time per day, total operation, darab 100. So kita nampak if we can have the most kita dah kira projected begini saving dia, dan kita dapat the most of what we plan, sama dengan apa yang kita project. So kita akan dapat 31.33% of productivity impact. However, if we go to 65% or 0.65, we will get the conservative productivity impact. It's not bad, not too bad. We get the 20.37 of the percentage of the productivity improvement. Alright, some people think that usually production demand is already being met. No need to increase production. So the question is, what to do with the extra time resulting from the economic intervention? Sebab yelah kan, production okay sahaja. So selama ni pun productivity pun terbaik. So kat sini lah kita nak tengok, bila kita ada extra time, ada benda yang kita boleh buat dengan extra time yang kita dapat. Sebagai contoh, when we have extra time resulting from the economic intervention, we can do additional quality check. From that, we can improve our quality, our product quality from time to time. We can do also cleaning more frequently. So we can have a very clean workplace, and also we can do stretching and maybe play with friends, main ping-pong ke, main chess ke, and secara langsung dan tidak langsung dia boleh meningkatkan kadar kegembiraan ketika bekerja. This is the application of step analysis. On the left of slide, there is a before poor layout. When you have poor layout, the issue could be lack of continuous product flow and excessive working with product. So from the picture, still in the left picture, you can see the numbering 1, 2, 3 until 10. 1 is represent for the starting step, and the 2 is the second place that the workers need to walk to. 3, 4, 5. As you can see, there are unstructured workflow, which is can consume a lot of time to complete the task. Okay, then the improvement has been made. As you can see, after the improvement, U-shaped work cell has been proposed. Based on the improvement, improved product flow, reduced prolonged or multiple handling, and motion savings that been introduced is 34.8 seconds per cycle. If you can see at the second picture, there are some of the activity has been removed, which can reduce the walking activity. So it's reflected by the motion saving that has been obtained. Improvement were made to eliminate non-value added tasks to reduce motion waste. Okay, ada buah tangan kat sini. So this exercise need to be completed by students. Fill in the blank. Try to question part A. Try to fill the projected and conservative motion time saving. Alright. Okay, based on the finding that you obtained from the previous slide, please to answer the following questions. Calculate total time saving per day, calculate total money saving per day, calculate the productivity impact. So please consider the projected and also conservative productivity impact. That's all for this topic. This is the reference. You may go to the Handbook of Economic Design Guideline version 2.0 from Human Tech 2009. And if you guys have any questions, you may contact me personally. With that, thank you so much for your kind attention. Assalamualaikum.